Alright, okay guys, so in today's lecture, sorry, I haven't shared my screen yet. Okay, alright, can you guys see my screen?
Yes, better.
Okay, alright, so actually I first want to explain about the lab, right? But it's going to be lab 5, but since that I think most of you guys, don't understand lab 3 until lab 6, so I'm going to do in the lab session. Of course, I'm going to record it for you guys, right? Okay, so all right, so I'm going to cover about the Mealy and also the more, right? So this is regarding a finite state machine. So finite state machine is really important for you guys to to use in your mini project, because this is how you're going to control the state of your your design. All right, so actually there are many types of state machine, but in our class EKT 221, mainly we're going to focus on Mealy and more machine. So these are both are state machines, but they what do you call it, they work in a different way. All right, so first we're gonna look into more machine first, right? So more machine, more state machine. All right, so if you guys see here, so there's a reset button and there's an input, and this is a current state, and then here is the next state, and here is the output. All right, so if you guys look into this diagram, right, so how we can read this, right? Let's see first, right? When reset is 1, so the input state is reset, the current state is reset. Okay, then we start it when the reset is 0. When the reset is 0, okay, let's say the input is 0. Okay, let's say the input is 0, then the current state is A, and the next state is B. Guys, this is example, right? So you can design your own more machine, but using the principle, right? But this is one of the example of how they design more machine. All right. Okay, in this case, the designer said if the input are being set to 0, then the next state will be B. All right, so whenever the input is 0, then it's going to move into the second state, which is state B. But if you guys notice, so here, the output is still 0. Sorry, the output still remains 0, because it's depend on the previous output here. For more machine, right? For more machine, you want to see the value of the output is in the bubble here, or in the circle, right? A is the state slash, and then 0 is the output, right? And then the input is here. Input is the let's say X, right? X is the input, and then the output is Y value. So in this case, when we give 0, so it just move to it's gonna move to B state, right? But the output value will still be relying on the previous, right? On the previous value of the state, right? Because it hasn't changed according to B state yet. Right? So, okay, but then if within the B, right? So if then, let's say, right now the input, okay, when at the B state, right? So currently we are at the B state. So when we are at the B state, and then let's say the input is 0, then it's going to remain in state B, right? State B, then the output is 0. And then, okay, let's see when it goes from B to D, right? So, okay, now current state is B. Okay, now let's say the input is 1. When the input is 1, then the next state becomes D. But if you guys see, okay, the next state is D. But the output should be the output at D, right? Should be the output at D is 1. But you see here, the output is still 0. Why? Because it's just moving to D. but it hasn't go into D yet, right? Okay, then, okay, after it arrived at D, right? After it arrived at D, okay, then the output is 1. All right, okay, I know it's a bit confusing, so I think let me draw it, right? Okay. Let's take this clock cycle first, right? So that we can see the changes with respect to the clock cycle. Right, so this is our clock cycle. All right, so this is T0 and this is Tn. So it is increasing. All right, so let's see based on this slide, right? Okay, so right now, okay, let's see. Okay, let's work on here. All right, so from B to D, right? Okay, from B to D. Okay, then how it's going to go to B? Okay, this is the input. Right, so let's say this is our input. Okay, when clock is high, okay, current state, right? So current state, right? CS. Current state now is at T, let's say this is T equal to 0, right? T is equal to 1. Okay, let's say at T is equal to 0, current state is B, right? Okay, so current state is B at T is equal to 0. Okay, now let's say the input is 1. Okay, now, okay, then we give the input high. Right, so the input has to be high when the clock is high. Right, so it's high. Okay, what happened is that at this clock cycle, the next state will be D. Okay, input is equal to high. Okay, then we make it low. Input is low, right? At the next clock cycle here, so at T is equal to 1, so this is T equal to 1. So this is T equal to 1, right? So at T is equal to 1, okay, now we are in the D state, right? Because when input is high, so the next state is D, right? So now we are at D state, right? So we now at the D state. Okay, this is current state, right? Okay, this is our output. Okay, so for our output, right? For our output here, okay, when T is equal to 0, when so at B, right? So at the state B, look at the output here. So output should be 0 because here at the state the output is set to be 0. This is we set it, right? So whenever they go into this state, then automatically the output is 0. If it goes into this state, then the output gonna be 1. Right? So the output is 0 here. So at T1, right? So it already moved in T1, but it hasn't go into T1 yet. So the output is still 0 at T is equal to 1. Okay, right? Okay, then after T is equal to 1, then here at this time T is equal to 2, right? So let's say T is equal to 2, then we are still in the D state. The output is 0, right? The output is 0. The input is 0 here. Input is 0. Input is 0, right? So the current state is D, but the next state is E. Okay, then the output is 1. Here is 1. So if you guys realize, I mean the effect, right? The effect after we give high, it takes 2 clock cycles to see the effect. So this is for more. Right, so that's why I'm telling you guys. So it's like if you guys look into this diagram here, yeah, in more, right? So there's like a transition state, right? So this is state 0, right? 0, 1, and 2s. All right, so let's say, this is the same state here, right? So this is both are the same state. So like it goes into here first, then another clock cycle, then it goes into here, then the output will change. So that's why you see here, the effect of the output you're gonna see after 2 clock cycle. This is more. All right, so okay, let's go into Mealy, right? So let's go into Mealy. Okay, then what about Mealy? Okay, for Mealy, all right, so that's why you see Mealy, the way they draw the block is different, right? So if you see the what's inside the circle is just the state, right? So it's either it's state A, state B, or state C. Whereas in more, you can see they specify the output here. It is inside the circle. But for Mealy, they specify the output here at the arrow. Okay, let's see here, right? Okay, let's see here. So when reset is on, then input is reset, current state is reset. Okay, when reset is 0, then input is equal to 0, then the current state is A. The current state is A, the next state is B. It's already going to B. Okay, but here the output already changes 0. It does not wait to go into B and change, so it's immediate change. All right, okay, let's draw the diagram. Okay, let's draw by referring to the same timing diagram, right? So let's see, this is the same timing diagram. All right, so this is input, right? Input. All right, so more is up here, right? So now we are explaining the Mealy. Okay, let's say now, okay, the input for first one, right? So input is 0. Input is 0 for the first clock cycle. All right, so the current state, okay, actually I should add the next state, right? Okay, let's do it for this one. So this is a current state, and then here is the next state, and here's for the output. All right, so at t is equal to 0, right? So t is equal, erase it. Okay, at t is equal to 0. Hey, by the way, can you guys follow the explanation? Give some feedbacks.
Yes, yes.
Okay, all right. What about others? Okay, good. All right. Okay, good. All right. Okay, now we are explaining Mealy, right? Okay, at t is equal to 0. So at t is equal to 0, when input is equal to 0, okay, now input is equal to 0, okay, current state is A. Next state is B. Okay, but the output we need to take from here, 0. Right, so the output is 0. Right, so this is when input is equal to 0. All right, okay, now, okay, input is equal to 0. Now we are at the B state, right? Okay, B state, okay, then, okay, at the B state, right? So current state is B. Okay, current state is B. Okay, now we set the input is equal to 1. All right, okay, now, let's say we set the input is equal to 1 here. It has to be right before the what they call it, the positive edge of the clock, right? So when the positive edge of the clock, it's already need to read 1 value from the input. Okay, then when they read 1 here, okay, what happened? When they read 1, so the next state is C. It's going to go into the next state. Okay, now at T is equal to 1, so it's already in the current state of B. Right, so the next state is C. But it hasn't go into the C state yet, right? But you look at the output here. Right, the output is already 1. So it's immediate effect. That's why if you see in Mealy machine, there's no 1 clock cycle delay. But in more machine, there's a 1 clock cycle delay. Basically, that's the main difference between Mealy and more. All right, so why there's a different way of designing? Of course, a different application. Right, so if you guys you are working in some real time, right? So you want to have immediate effect, then of course you're gonna use Mealy. But if you guys are using working on something that need to have a security measure, right? So there's another signal that you have to check, right? So it's better go on more machine, right? So there's a precaution, or a buffer state, so that you guys, before you guys are making the decision, what the output change. All right, okay. So basically, I think there's a Mealy and more, right? Any question on Mealy and more?
Sir,
Yep.
Mealy for the T1.
Mealy for the T1, okay.
How can the output become one?
Okay, how the output become 1, eh?
Yes.
Okay, all right. So look here, right? So look here, okay. Look from the table, right? The table and also the diagram. Okay, we see here. Okay, when the current state is A, right? So when we are here, so when the input state, the current state is A, when the input is 0, then what happen is that is going to go into the next state, which is B, right? So B, and then okay, when it going to B, the output will follow the next output value, which is B, right? So this uh, 0 represent B state, right? So but it's the changes happening on the spot, not like more machine, for example, right? So the value in the next state here in D state is 1, but as it moves to D, right, the output value will not change yet. It's going to follow, carry the 0 value. It has to wait until it goes inside the circle, right, which is another clock cycle, then the output will change into 1. Okay, but here, as it goes into B, the output already changes. Okay, now your question is on T2, right? So on T1. Why the output becomes 1? Okay, let's see. Okay, so this is Mealy. Okay, now we are in B, right? B state. Okay, so now there are two conditions. The first one, right? So the first one, if the input is 0, then the output is still 0. But if the input is equal to 1, right? So if the input is equal to 1, see here. So, oops. Okay, now we change the input, right, to 1. Okay, what happened is that when input is equal to 1, the next state is C, right? Refer to the table here. The next state is C. So it's going to the next state. All right, so next state is C, current state is B. Okay, as it goes into the next state, okay, now we see the output value here. So what the output value here is stating, it is 1. Right? Okay, so the output value we refer to the number after the slash here for Mealy. But for more, the output refer into the number inside the circle. Yeah, of course, same next to the slash too, right? Okay, that's how we get the output equal to 1. All right. Can I understand? Amaliana.
Yes, yes.
Okay, all
Thank you,
right.
sir.
Okay. Is there any other question, guys?
No.
Okay. All right. What about the rest of you guys? Do you have any question? Okay. So say the input and output regarding the table, is it fixed or we have to assign for? Okay, this is a good question, right? Okay, for this table, right? So the input and output. So is it fixed? No, it's not fixed. So who going to design it? You are the one who going to design it. Right? So it depends. So that's why you see here, I mean like here, I mean it's only one when it goes into C, right? But if you want to go when it goes into C, it's zero, and it's zero. Right, so basically this is your control signal, right? Okay, let me do it here. Right. Okay, let me show you guys into some design example, right? Okay, let's say you want to do the let's say washing machine, right? So I think that's the easiest one. You guys know, I mean, because you guys are using the washing machine. I think most of you guys use washing machine, right? So there are few cycles, right? In the washing machine. Okay, let's say state one, right? State one, input water, all right? Input water. Of course, this is including your detergent or softener or whatever that you guys want to include, right? And then the S2, okay, let's say S2 is rinse. Rinse, and then let's say after rinse, S3, state 3, flush. Flush the water. All right. Okay, now we have three states, right? So S1, S1, S2, and S3. Okay, what's happening here inside the S1? All right, so what are the things that we need to control to input the water? All right, so input the water. So they're going to be a control signal, right? So let's say our signal is, let's say, valve, right? Water valve. So water valve. Right, water valve A is equal to 1. Right, so this is your, let's say this is your washing machine, right? Washing machine, and just of course it's within here inside, right? So let's say there's a water valve here, right? So you need to have a control signal. So it's A to control the flow, input of the water. So during this state 1 cycle, this is your output, right? But how are you going to go into this cycle, S1? All right, so this is your what do you call it? I mean, how you move the state, right? Okay, first, okay, let's set the output first. Okay, what else? Water valve. Then how you gonna know that? Okay, there's a condition, right? So let's say there's a sensor here. So there's a water level sensor. All right. So I mean, whatever. Okay, let's say it's a water level sensor. Level sensor. Okay, so when the water level sensor, okay, let's say this water level sensor is equal to B, right? So if B is equal to 1, let's say the water is going up, right? It's going up until it touch the water level sensor. When it touch the water level sensor, of course, the sensor will detect and start to send the current or the signal, right? Send the signal. Okay, now if it detects the water level has reached a certain level that it should reach, right? Then send the signal B equal to 1. So if B is equal to 1, then set A is equal to 0. right? Assign A is equal to 0. Okay, then what happened? All right, so this is where you determine your condition here, right? So how you gonna move the what do you call it, to the next level, right? So there's gonna be a clock cycle, right? So you have a clock cycle. So at every clock cycle, I mean, what are the input that you have to check, right? Okay, then you can set your state here. Right, set your state. So if B is equal to 1, then when the water has reached a certain level, right? Okay, then state, right? Okay, Mahirah Nabila, can you mute your mic? Mahirah Nabila. Okay, thank you. All right. Okay. As you're gonna be famous in the YouTube, right? Because you are adding extra background sound in the lecture. Okay, guys. Okay, so now we set the next state, right? So next state is, let's say S1 is 0, 0. So here is 0, 1, right? So go to next state. Okay, so every clock cycles, you're gonna check the state, the next state, right? So if the next state is changed, then move, right? So before the water level reach the level, sensor level, right? The current state is equal. Sorry, wait. The current state. Okay, this is going to be current state, right? Current state, and then next state is equal to 0, 1. Okay, here's the current state, right? So let's say current state. Current state, right? So current state is 0, 0. Right, so set next state is equal to 0, 1, then set current state equal to just ns now, guys. It's too long now. Here is it. Okay. All right, so ns. So just assign to ns. Right, so every clock cycle check for current state. So then, I mean, at the positive edge of the clock cycle, is going to check, right? So it's going to check, okay, if it is high, then check. Okay, now the current cycle, current state has changed to 0, 1, right? So now move to 0, 1. Okay, 0, 1 is rinse, right? Okay, rinse means that you're going to start to rotate the motor, all right? So there's a motor here, right? That's going to hold this. There's a bucket, right, in your washing machine. So this is your motor, right? They're going to control the rotation, right? C. Okay, of course, there's a mode of moving the motor, right? Okay, but we just make it simple. Okay, now at state 2, then what you're gonna do? So set C equal to 1. Okay, how long you're gonna set it? Okay, I mean, it's depend on the complexity, right? So let's say, I mean, you have a different water level, right? So let's say you have 3 different, or not water level, 3 different laundry size, right? So mean 3 different laundry size, right? So let's say S small. Oh, okay, this is the minimum one, and M medium, and L large means that this is medium size of laundry, and this is large size means that you occupy, I mean, the until the assigned section, right? Not like what you guys did when you guys did your laundry, right? You guys just top up until at the lid of the laundry, the washing machine, right? But actually there's a assigned level which it should you should be putting your laundry at the maximum level so that it's going to be optimized. Okay, so this is the L. Okay, so based on this size, right? So let's say, I mean, you want to increase your complexity of design. This is can be your reference in your mini project too, right? Okay, so let's say it's small, right? So small, the time for the rinse, okay, let's say for small it is 8 minutes. For medium, let's say it's 16 minutes. So for large, let's say it's a 32 minutes, right? Okay, now set a counter, right? So you do your counter, right? Counter, right? To count 8 minutes, right? So I've told you guys how you guys can do the counter and how you can set it based on time, right? The calculation. So you have to know that, right? So count for 8 minutes. Right? So it's gonna count for 8 minutes until it's finished, it's done. Okay, then change again the next state, right? So next state, what is the next state? So this is an example how you guys can use so I mean you are the one who assign the output value, you are the one who assign how it changed to another state, right? So that's the function of state diagram. Okay, all right, any question up until here, guys?
No, doctor.
Okay, good. What about other students? Okay, yes.
Regarding the state, the S1, S2, and S3,
Mm-hmm.
if the state in S2 can be written in S1,
Mm-hmm.
is it possible?
Yep, it is possible. So
So,
because you are the one who said, okay, so
so in S1, if there is multiple if else, is it possible like that?
there's a multiple what?
Multiple if else condition or state or case. Uh, is it possible like that?
Mm, multiple if there's a multiple, yeah, it's possible, but it mean it has to be, for example, right? If b is equal to 1, then else if, then else if, right? So it's a continuation of checking the condition. Boleh tak, Firdaus?
Okay, okay.
Alright. So you can have multiple condition, but just adding to this condition, right? If B, then else what? Check what? Then else check what? Else check what? Something like that. Right? Because you remember, right? So there's a parallel, right? Parallel, and also uh, what do you call it? Parallel, and also sequential execution, right? So if else, of course, it's going to execute in sequential. It's not be execute in parallel. Okay, good. Any other question, guys?
No, doctor.
Alright. Amaliana should get extra mark because she's the most proactive one. I should have adding a mark section for that. Okay, good. Right. Any other? Okay, if there's no question, then let's go into. Yeah, I'm covering the topics that I think is necessary for you guys uh, to know for your to help you guys in your mini project. Okay, algorithmic state machine. Right, so this is our next topic, right? Again, this is in helping you guys to design, right? So is it possible reset back to 1 in the middle of procedure? Yeah, you mean it is possible. So it's depend on your application, right? So if you guys realize, for example, right? For example, washing machine, right? So sometimes if the load is not stable, right? Then they're going to give you some error code, right? So for example, let's say the load is not stable. When it start to to spin, then the washing machine will wobble, right? If it's wobble, bergoyang, right? If it's wobble too much, then and then what happened is going to trigger the error code, right? So you have, I mean, the trigger to error code which need to the involvement of the user. So the user has to go and adjust the load and then close the lid again. So whenever it's closing the lid, it's gonna reset. So it's gonna restart at the beginning of the current state. Let's say it is in the rinse state, right? So it's gonna begin from the rinse state. Okay, let's say right now you want to reset it to go to the beginning. All right, so what you're gonna do is that, I mean, like for example, washing machine, what you're gonna do, you have to power it off, right? So power it off, I mean, like main reset, then it's gonna go into the first cycle or first state. So it's depend on your design, right? So if you are in whichever state, let's say you have three state A, B, C. I mean, you want it to go after you press the reset. You want to go to direct to state one, right? So you can do that. So it's all based on your design, right? Wei Shen, is it answering your question? Okay, all right, good. Okay, now we go into algorithmic state machine, ASM, right? Okay. Okay, basically, guys, when you guys are doing the design, right, or coding, we don't start just simply from the coding, right? So that's why uh, normally what we do first, we sketch first, right? We sketch the flow. All right, so we normally, if you guys are doing coding, right, or even if you guys doing whatever AC whatever, right, so we need to have the skeleton, right? We need to have the flow. So that's why, I mean, we have to create the flow first, right? So you have to begin from what, right? So begin from what, then next state is what, right? So you have to specify, design the state. If in this condition, right, what happened, can you move back here or you move to another block, right? So I mean, this is the skeleton of your design. And then there's a method that we can learn to help us in the design, right? So we don't really mean like the designer, right? You ask them, okay, please do this coding, and then they just start the coding. No, they're gonna draw the block diagram first, draw the flow, right? Check whether the flow is okay and whatever. Then the final step is to do the coding, right? So this is the step in design, right? So we start from the abstract level first, right? So the idea first, the flow, right? Then we go into coding, right? Same goes into when you guys are doing your project later, your FYP or your, I mean, even in mini project, right? I mean, that's why you have to include this block diagram, right? So to help you guys explain how your design is, I mean, even to help you guys understand better your own design, how it moves or and so whatever, right? Because for example, there was one student, right? I mean, asking me why the operation, for example, for your ALU changes like this, right? So I mean, how you gonna know that? I mean, actually, it's based on your coding, and then actually before you go into coding, then how you know that? I mean, is really depend on your abstract design first, right? So your abstract design first mean how you, for example, right? So let's do it here, right? So it's easier, I don't have to change slide. Okay, so for an example, right? So for an example, your ALU, right? So ALU mean it's being controlled by the counter. Okay, let's say you have a 3 bits counter, right? So it start from 000, right? And then start and then goes to 001. 001 and 001 0. Okay, so when it goes into counter 000, so what you want to do, so let's say you want to have add here, right? So you want to have add here, then you have to look into your design, right? So you have marks here. So which one is, this is your subtractor, and then here's your addition, right? And then here's your multiplication, for example, right? Multiplication, then you connect it to your marks. So let's say this is 3 to 1 marks, right? So 3 to 1 marks, right? So you have to know within the marks itself, right? So which one is let's say you have 3, right? So you need to have at least 2 bits. So 00, 01, and also 10, right? So if you want to do addition, so at this counter, so what's the signal that you have to send? So you have to send to the mux. Let's say this is your mux control, right? Mux control. So your mux control is equal to addition, right? So it's a 0, 1. Right, so basically, I mean, you mean at least you understand the flow, right? You know how the flow. I mean, let's say you can explain. So this is your state, 0, 0, and then what happened in the other state, and then what happened in next state, right? So basically, that I mean, this is not in a good-looking flow chart, right? But actually, you guys can improve it. But you have to have this abstract level first, right? In a digital design, because this is the thing that we I mean, like what's happening within the circuit, we cannot see it, right? So, but how we can deal with it, right? So we have to use our imagination, right? So by understanding the whole design, right? So it's going to help us to understand better how to complete our design, how to work on our design. Okay, right, let's go into here. So I think you can read this, but I think let's go into example, right? Okay. Now, all right, so let's go into example, right? So block diagram will help us in terms in our design, right? Okay, so for example, right? So this we start our design, so it's available, right? So at first condition is going to check the input signal, right? So the input signal. So if the input signal if 0, then you just wait, right? So until you receive the start signal equal to 1, then you start the process. Right, so you start the process. So what happened here, you just assign the A equal to 0 value, right? So this is your own design. This is just example, right? So, and then go to the next process, right? So it's go to the next process. Here, check the condition, right? So there's a 2-bit here, 0, 1. So there's a 2 bits. So if Q is equal to 0, 0, then go to multiplexer 0. If it is 0, 1, then go to multiplexer or multiplication here. Yeah. Okay, so whatever, go to mul 1 block, right? If it's 1, 0, go to mul 2 block. If it's 1, 1, exit or go to mul 3 blocks. Right, so I mean this is the example, right? So of the ASM document. Exit, okay, wait. Start state idle, okay, available is equal to 1. Okay, then start equal to 0. Next state is idle, so idle. All right, so and then start equal to 1. Next state is A is clear to 0. So then depending on the value of Q0, next state is either mul 0 until mul 3, right? Where the entry pass and the 5 exit pass for the ASM block is labeled at the boundaries of the ASM block. Right? The entry pass and the 5 exit is labeled. Right, so the labeling of the blocks, right? Okay, all right, so let's go into example here. I'm not explaining the theory behind this, so I'm explaining to you guys how you guys can do with the design, right? Okay, let's look into this example, right? Okay, analysis. Okay, state idle available equal to 1, right? Okay, state is idle. Okay, here is the state. Okay, now available is equal to 1, right? So if available equal to 1, then go to the right side. If it is 0, then goes into the left side. Right, so the next state is to increase R. Right, so next state is to increase R. If start is equal to check this. If start is equal to 0, next state is increase R. Okay, of course, sorry. Okay, then available equal 1, then check, right? So check whether start is equal to 0. Okay, this is the signal, right? So this is the signal that we want to check inside the block. Right? So this is the state. Right, so this is the state. Right, so now it's in the state idle, right? So check if the available is equal to 1, then go and check the start, right? So if start is equal to 0, then go to the left side. If start is equal to 1, go to the right. Okay, so what happened when you go to the left? The R is increment by 1. So R is equal to R plus 1. If R is equal to 0, now R is equal to 1. But if start is equal to 1, it's going to go to the right, then it's going to reset the value. Whatever the value of R, then is going to be assigned now to equal to 0. Now R is equal to 0. Okay, then depending, start, okay, next clear R, okay, then next, depending on value of Q. Now, if it goes to left, of course, it's going to go back into the ideal state, right? But now, if if start is equal to 1, then R will be assigned to 0. Then it's going to check the condition. If Q is equal to 1, then it go here, right? Then exit, go to mul 1. If it's 0, then exit equal to mul 0, right? Okay, this is in terms of the timing. All right, can you guys follow me? Right, up until here?
Yes, doktor.
Doktor, nak tanya,
Ya,
yang dalam kotak besar tu dia punya proses lah.
yang ni ya.
Ya.
Ya, betul, proses.
So, mile 0 dengan mile 1 ni dia akan jadi output lah.
It's output, but you can set now what's happening inside here.
Oh, okay.
Alright. So, but in this condition, macam state ni, so in this block, right, so it's going to check the value of available, right? So, what's the value? So, okay, then this is a decision making, right? So, this is decision making. But if it is a multiple decision making, you use this kind of block. Okay, all right. Any other question before I start to explain the timing considerations?
No, doktor.
All right, good. This is Tinoria also can get extra mark. Flow chart. Yeah. This is a flow chart. Right. Okay, all right. So ASM timing considerations, right? Okay, clock cycle 1, clock cycle 2, right? Okay, at clock cycle 1, then start is equal to 1, right? So if start is equal to 1, so available is already 1 here. Oh, sorry. Okay. So available is 1, right? So remember, right? So available need to be 1, then it's going to check into start, right? So it check into start. So if start is equal to 1, what happen? R will be assigned to 0. Yes, R. Okay. R is here. Output available 1 input this is equal to 0. This is start is equal to, okay, idle, then second clock cycle Q0. Okay, check the value of Q0. Right, so check the Q. Okay, this is the first clock cycle, right? So you check the condition here. So start is equal to 1, right? Start is equal to 1, go here. Then assign the value to 0. Okay, then second clock cycle, check. Second clock cycle here, check the value of Q0. Alright, so here Q0 value is equal to 0. 0 or 1? This one. Oh, it's 1, right? So it's 1. Because it's up here. So here's 0. So this is 0. This is 1, right? Right, so the value is 1. So when the value is equal to 1, then go to mul 1. Right, so this is how you translate from the block diagram to the timing diagram. Okay, now the second condition here. Okay, so set Q1. Oh, this is explaining the same thing, right? Okay, this is explaining the same thing. Okay, okay, all right. Okay, now let's say the available, right? So the availables goes to 0. So if the availables is equal equal to 0, what happened? Present state idle. Okay, present state idle. Start is equal to 1 at the second clock cycle. So start is equal to 1. Next clock cycle, beginning from clock cycle 3, register A is cleared to 0. Why register A is cleared to 0? Okay, let's see. Register A is cleared to 0 if the start is equal to 1. Of course, yeah. So the start is equal to 1 here. Register clock cycle 2. Cleared to 0, Q1 is examined. So Q10. So this is Q10 is a 0, 1. That's so fast. Okay, this is again, I think, same thing. Clock cycle 2. Okay, then what happened at clock cycle 3? So present state, mark 1, register A is equal to 0. Okay, right, so at clock cycle 3, I mean, this is the result, right? So after cycle 2, I think that's all the explanation here. Yeah, so the changes take place here. You can see change, right? So clock cycle 1 here, they check the condition, right? And then clock cycle 1, so they check here, start is equal to 1. Then it moved to clock cycle 2. Then the value mal is updated based on the condition check here in this diamond box. Yeah, I think basically that's all for this part, right? So ASM topic, which is the algorithmic state machine, right? So this is how you create your block diagram for your project, right? So of course, first basically you need to have your state machine. All right, then after that you need to have your block diagram to show the flow of your project, and then you start your coding. Right, so that's step by step on how you're going to do your project, right? Okay, but guys, even in the block diagram, right? So there's a level of block diagram, right? So if you guys realize, I mean, for example, right, so you can have a very high level block diagram, right? For example, for your project, right? So begin your project. So let's say this is your literature review. Literature review means that you are studying, you find your references, right? And then block diagram design, for example. Right, so this is a very high level on block diagram, and then design, right? And design level, right? So inside this design, right? So you can have a more detailed block diagram. So how you design it, right? So you have whatever condition. So that there is going to be can have multiple level of block diagram. But the one that we are concerning is the detailed one, right? So how your design flow, how it function, which signal that you're going to activate, something like that. All right, so I think that's all for today's material, guys. So I think the materials covered enough for you guys to begin your mini project. So by next week, I'm going to release the document for your mini project. And by now, I think you can start to find your friends. You know, my idea is that, I'm not sure how it works for you guys, but within your group, you need to have a mixture, right, of students, maybe like a bright student, smart student, good in coding, and of course, you can take some of your, your friends that need some help, bring them into your groups too, right, so that you can help them. So I mean, this is the leadership. If you guys know that you guys are good, you know yourself, right? Whether you are good in coding or not. So if you think you are good, then you have to open the opportunity for your friends, to be with you so that you can help and guide them. If you guys are weak student, then you don't put yourself in a group consists of all weak students. Right, I know, right? Some of you guys have, already clicked, right? Have a like a specific group. right? But you have to move out from that group. So you have to go and find I think, I mean, among you guys, you know, right? Who's your friends that when they receive the lab assignment, this the guy that the first one gonna finish it. So you're gonna wait for them to release their answer sheet. Then you guys gonna copy from them. Then you know who are this person and who are this person that can help you to understand. So you have to find this kind of person and join their group, right? If you guys want to learn, right? So in this group, right? So it's not just about coding. It's going to be designing. It's going to be writing a report, right? So there's many elements in here. So it's not necessary that you need to have a people that are just only good in coding, but you can have a different, variation of group members in your group. So basically, in the mini project, you guys need to have 5 students per group, right? So that's the number that we set for you guys. Of course, the number of total student, I mean, I think so 138, right? But maybe there are some groups that will be consist of 4 students. But basically, 5 is the number, right? So you have to find the number 5 first. I mean, if you guys have put enough effort, then cannot move into 5, then let me know, right? Then we can put some consideration on that. All right. Any question, guys?
No, Doctor.
No, Doctor.